بعد هذه المقدمة لتطور تحليل النظم ومجال تطبيقاته، يتضح أنه علم متعدد الأوجه يضم العديد من المهارات التي تحتاجها علوم المنظومة، ولذلك فمن المتوقع أن يستمر هذا العلم المتجدد في مواكبة التطبيقات الحديثة لهذه العلوم. في نهاية هذا الفيديو سيمكنك التعرف على استخدامات تحليل النظم مع العلوم الحديثة للمنظومة، مثل النظرية العامة للمنظومة، تكنولوجيا المعلومات، الذكاء الاصطناعي، تحليل البيانات والتعلم الآلي، وبحوث العمليات، وتقنيات الحل الأمثل، وهندسة النظم. ستصبح أكثر إلماما بالدور الذي تلعبه المعلومات والأهداف المتعددة لاستخداماتها، خصوصا مع تراكمات إنتاجها في قواعد البيانات الضخمة التي تعمل مع تطبيقات الحاسبات، وهذا ما سنناقشه في المحاضرة القادمة بعنوان البيانات والمعلومات. هذا وقد تم إخراج التسجيل الصوتي لهذا الفيديو باللغة الإنجليزية كتدريب لمحللي النظم الجدد وللتعرف على مصطلحات علوم المنظومة. In the following sections, we give a simple review on how systems analysis becomes part of the modern systems sciences, as general system theory, information technology, data analytics, machine learning, artificial intelligence, operations research, optimization techniques, and systems engineering. General systems theory was formulated by the Asturian biologist von Pertlamphy in 1949, which opened the door to systems science, which is then called the science of sciences. From this theory, systems approach and system thinking emerged and were used to solve many problems in different applications and contributed to developing new systems analysis methodologies and tools. Information technology is always associated with computer-based information systems development project. Systems analysis is used throughout all stages of the project, starting from defining the problem and then determining goals of the project and up to the stages of its operation and information production. Data analysis is an important part of systems analysis tools, both in the problem definition phase and in the project definition and management phases. With the emergence of smart data analysis systems, it becomes possible to automate collection, preparation, transfer, and testing big data, which can be processed in a way that allows the formation of insight, trends, and predictions. Machine learning is a branch of artificial intelligence and is the technology of transforming computers into devices that can learn and behave as expected from humans. With the integration of machine learning software into the corporate information systems, the produced information and data can be analyzed to reflect the condition of commercial markets and consumer trends, which then can be extrapolated to provide strategic insights to decision makers instantaneously or in real time. Systems analysis plays an important role in realizing this integration. Artificial intelligence is a science and technology through which machines can be transformed into intelligent devices that can perform tasks like humans. The development of this science has been attributed to the superior ability achieved by the capabilities of storing, transferring, and processing large data and information used and produced by information technology systems. Systems analysis plays an important role in crystallizing problems and defining their requirements for using such applications. Operations research is the science of building mathematical models of problems domain where it can search for optimal solution in that domain. Therefore, systems analysis becomes important to study the problem area, determining its variables along with the feasibility of its solutions and its expected constraints. And therefore, there was always a strong connection between the two sciences. Systems analysis always searches for optimal solutions among alternatives, especially during the feasibility analysis phase of the system's development life cycle. With the advancement in data analytics algorithms and various machine learning techniques, it has become possible to achieve the best options, even in the absence of the need for human interventions. This has been reflected in reducing the cost of projects and the duration of their implementation. Systems engineering is associated with solving problems encountered when developing and implementing large and complex engineering projects. Systems analysis is used as part of systems engineering in relation to studying the feasibility of projects from its economic, operational, behavioral, and political aspects. In addition, systems analysis has now become more widely used with computer systems engineering and various types of software engineering studies. In conclusion, systems analysis was developed by the RAND Corporation in 1948 using ideas from systems engineering and operations research and board planning tools and feedback loops from cybernetics. As RAND's scope was broadened, it introduced systems analysis to serve as a methodological basis for social policy planning and analysis across such disparate areas as urban decay, poverty, healthcare, education, and efficient operation of municipal services such as police protection and firefighting. And in 1961, US President John Kennedy required the use of systems analysis techniques throughout the US government to provide a quantitative basis for its decision-making problems. The lecture presented how cybernetics and general systems theory influenced the evolution of some of the main systems analysis new methodologies, such as soft system methodology, system dynamics, and actions research. In the meantime, systems analysts will continue to play different roles with the new applications and use of systems analysis as digital marketing, human technology, culture change, and knowledge management. Now, systems analysis should be considered as a science, skills, a career, and a profession. With this advancement of systems sciences, systems analysts must acquire many new skills to cope with the present changes. Managers also must become familiar with these new skills so that they can understand the implications of the administrative development of their organizations. Also, corporate and institutions have become more obliged than ever to pay attention to creating ambitious career fields for this important profession. One should be convinced that system automation or digitization does not mean just adapting new computer technology. Systems analysis should not be limited to implementing or installing computer applications as is common now, especially when the goal of information system has shifted from generating data and information to generating knowledge, or as the world is shifting from the model of information flow within organizations into the present model of the societal information field. This is supported also with the widespread transmission of information through social media and its internet marketing and associated systemic behavioral change campaigns. These behavioral changes come from the sophisticated processing which gives more value to data collected and accumulated in the big databases linked to computer applications. And this what we will be discussing in the next lecture titled Data and Information.